So I'm going to briefly talk about desalinization, which is introduced in the book. It's not really oceanography, but obviously it's part of human life, and hence has become part of oceanography because the number of desalinization plants is going up. And as I mentioned before, even though we have so much ocean water, more than 97% is undrinkable because it's got so much salt in it, and only about less than 3% is fresh water, and we said more than 2% of that is locked up in glaciers, which leaves us with very, very little surface water and groundwater. So there is climate change happening on top, which is changing the way rain falls, very heavy rainfalls, which we call extreme events, which we will talk about when we go to global warming, which means the water is going to run away. Plus, we are also deforesting, we are urbanizing, which also changes how much water actually soaks into the ground, and so on and so forth. So one of the biggest things that's already happening is scarcity of water. It's the physical scarcity of water, economic scarcity of water, and just physical access to water, and quantity of water, quality of water as well, right? Contamination, pollution of the water because of human activities, agriculture, chemical being released by the industries, and so on and so forth. Plus, there are countries in the Middle East which are very rich because of all the oil money they have, but they are deserts, so they don't have rainfall, not enough anyways. So they are all relying very, very heavily on desalinization. So even a country like Saudi Arabia, being a desert, actually grows wheat by using desalinated water, and they desalinate millions of liters per day to supply water to their citizens, right? So desalinization is basically removing salt from seawater, and life depends on fresh water. Humans depend on fresh water, and all the things, life forms that live on land depend on fresh water. But desalinization is very energy intensive, which means it's very expensive. Plus, energy consumption means you're again going to add to global warming. So global warming is creating water problems, and you're doing desalinization to deal with water problems, but desalinization is again adding to global warming. Most desalinization plants are in arid regions, as you can expect, but so far they still provide less than 0.5% of the water needs. But as I said, it depends on where you are. If you're in the Middle East, they're providing almost 100% of the water needs. There are various processes by which desalination is done. Distillation is the easiest way to just remove water and leave the salt behind, but this is obviously can be very expensive if you have to produce large amounts of fresh water for people. But solar power can be used, and it is being done in many places where solar energy is directly being used to evaporate water, and there is some kind of a plastic sheet on top of this tank which would collect the water vapor that's coming out of the salt water and then condense it. Obviously, scaling it up and accomplishing a lot of it per day is not a easy thing. So it's energy friendly, global warming friendly, but scaling can be very important, very difficult. And because there is so much salt in it, you end up with little bit of fresh water compared to the amount of energy that you are using, right? But if you're in a desert and you have a lot of free solar energy, maybe you can scale it up. Electrolysis is another way where you put two electrodes. Remember, salt water is conductive as opposed to pure water, which is, even though it's dipolar, the hydrogen bonds make it nearly neutral. So if you put electrodes in pure water, the molecules will just stick to negative and positive electrodes, and electricity will not flow. Whereas if you have salts, then you can actually flow electricity, and you can create electrolysis to generate fresh water. And you can also have a membrane. Well, they tend to have a reverse osmosis is now one of the most widely used methods for desalinization. We haven't learned osmosis yet, but I think you have some sense from your earlier education. You have some kind of a semi-permeable membrane which allows water molecules to pass, but not what's in the water, like salts, right? This is used in our body to exchange waste and oxygen between cells and so on, and all the animals that live in the water use it, etc. Where there is something called the osmotic pressure. And the simple principle, as we will learn later on, is that water goes from high water concentrations to low water concentration, which means it'll go from pure water to salty water. Salty water has less water molecules, fewer water molecules than pure water, right? Reverse osmosis puts pressure such that water with salt with fewer water molecules will be pushed to go into the other side. This is why it's called reverse osmosis. Okay, so a lot of times when you buy bottled water, you can read on it, it'll say reverse osmosis. Again, energy intensive, obviously being done at scale because a lot of water is being sold in bottles. And the other method is freeze separation, where seawater is brought into a pre-treatment center and it's frozen. Remember, freezing releases brine and the salts, and you are left with ice, which is almost free of all salts. But you have these freeze-thaw cycles, which also make it very expensive. So everything is expensive, especially because the quantities of water you're trying to produce is very large. Is this going to keep on increasing? All indications is yes. For a country like Israel, for example, solved all its water problems because it has a nice north-south coastline with the ocean on one side. It has basically used desalination to solve most of its water problems and do some super efficient agriculture with drip irrigation and so on. Okay, so despite the very small amounts of rain, with drip irrigation, water harvesting, and desalinization, they have become quite self-sufficient in food and in fact export many things. So desalinization may be here to stay. So energy efficient ways of desalinizing may become more important in the future. This pretty much concludes this chapter. So what I'll do is now show some animations to reaffirm some of the concepts. And so if the animations work, great. If not,